Okay, so today we're going to talk about something. It's basically how you're going to create a mini synth, a very simple synth that in Python or in Visual Studio codes. And so, one thing to say beforehand is that sound is basically, first of all, waves and vibrations. Vibrations. And these are basically very similar. And sound basically comes from calculating the waves and then turning them into vibrations. Okay, so without further ado, let's get started with creating some sound waves. And so, we're going to need two things. First of all, we're going to need NumPy. We're going to need NumPy to calculate. We're also going to need sound device. Sound device. This is going to hook up to our audio interface, and then it's going to help us turn our wave into the sound, into the vibrations. Okay. So we're going to first of all import these two as whatever you want, and then we're going to actually define a function. Okay, so we're going to define something called make wave. Def make wave, the underscore, and then it's going to take a few unknowns or few, what do you call this in English? Okay, so you're going to take a frequency. This determines what note it's going to be and the duration of the kind of sound, and then the type, the wave type, and then the sample rate. That's an underscore, and then the amplitude. You're gonna take a few things. Okay, so we're gonna calculate. First of all, we're gonna calculate the time, and then we're gonna calculate the phase, and then we're gonna go into the wave things. Okay, so first let's calculate t, because we need t for our actual waves, and so t is gonna be np lin space. This basically means that it's giving you basically equal amount. So the dots are equally spaced, basically. I believe this is what it does, but I could be wrong. Let me check. Let me circle this. Let me make sure that's correct. And then we're gonna give it a few components: duration, and then int sample rate, and then RAT sample rate times duration, and then the endpoint end is going to be equal to false. Okay, once we have that, we're going to need something called phase. This determines where our sine wave or any wave is. It's going to be 2 times pi, and then times frequency, and then times t. So if you calculate this, frequency is going to be equal to 1 over t, and then it's going to be 2 omega over 2 pi. So basically multiplying this gives you omega t, which is basically going around the unit circle. And then this is basically how much is spinning around the unit circle. This is kind of like the definition of phase. And then it's just writing it in like a way that we know, because we take constants, frequency, and time, right? Okay, so let's give a sine wave now. So a sine wave is just a very simple wave. So wave is going to be equal to amplitude. So all sine waves can be like a sine, let's say, omega x plus phi. I believe that's how you write it. I'm forgetting my trigonometry things. And then we're going to have amplitude in the front because we want that a. And then we're going to have, this is NumPy again, sine phase. So basically what we're doing here is that we're calculating all of the dots. This gives you a lot of dots as our t. And then the phase is going through the t, and then the amplitude is basically, let's say we have a sine wave here. Very ugly sine wave. Okay, that's bad. Notability is not doing me. So what we're basically doing is now we're taking dots on the sine wave, and then we're kind of matching the sine wave with like a bunch of dots. So that's basically what we're doing. And then the dots are going to convert to electric signals. So once we have the sine wave, and the sine wave is the easiest, and it just sounds, kind of weird. I can't describe the sound. It just sounds kind of murky, and then meh. It just kind of sound meh. And then we're gonna have the square wave. So the square wave is actually one of the easiest waves. Square is one of the easiest waves because the square wave is like this, boom, 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 boom. And then it's easy because you really only need to, there's only 1 and -1. So you really only need to kind of know know whether it's positive or negative. So we're going to do wave is going to be equal to, let's say, amplitude. Amplitude is going to be equal to amplitude times NP and psi G and not sine. So NP and sine phase. So we're going to have that. So this is going to give you amplitude as either this is positive or -1. And then it's going to be good. This is a square wave. And then a sawtooth wave. So a sawtooth wave is like this. And it's different from a triangle wave, which is like that. And then a sawtooth wave is a little bit more complicated. And then, well, it's going to be something like this. So the sawtooth wave, once we saw, it goes all the way up to the highest value, and then it drops all the way down to the lowest value, and then it goes up again. So what that does is basically, it's kind of hard to think about it, but norm, we're going to give it another variable, and then it's going to be equal to phase. So mod 2 pi. I'm just writing a 2 pi because phase is basically we're only caring about what part of the circle it's at. It doesn't care about how many rotations there are. And then once we have that, we divide it by 2 pi. So what this does is it tells you where you are in the circle. For example, you're at the third rotation here. It doesn't care, it only knows that you're there. And then divides by 2 pi, and it gives you a number between 0 and 1. So a norm is like a number between 0 and 1 and 0. There we go. And so once we have norm, there's kind of something that we need to do is that we need to stretch norm out. So wave is going to be equal to amp, and we're just going to call it amp times 2 times norm minus 1. So what this does is that when you're at, so this is going to be at 1. So when you're at 1, right, you're at 1, you're at the highest because if you're at norm and you're at 1, the phase needs to be at like 0, and then the norm is at the highest, and then the wave is going to be amp times 2 times norm is going to be 1, so it's going to be at the highest it is amp. And then what's going to happen is that as long as it goes past the x-axis a little bit, for example like that a bit, and then it's going to go to negative amplitude because basically what's going to happen is that norm is going to turn into negative. Yes, so this is the sawtooth wave. And I kind of do like the sawtooth wave a lot because that's just something that kind of sounds good to me. There's also the triangle wave. Triangle wave is a bit harder, and it just requires a lot more understanding. And I can tell you what the triangle wave does. So we're also still going to have the norm. Norm is going to be equal to the phase divided by, we're going to do mod 2 pi, and then we're going to do that divided by 2 pi, and then we're going to get an integer between 0 and 1. So the triangle is going to be basically, so 2 times, so this is between 0 and 1, right? This is going from 0 to 1 to 0 to 1 to 0 to 1 to 0 to 1, right? And then what we're going to do is that we're going to take, so remember how we did kind of amplitude? This is 2 times norm minus 1. What does 2 times norm minus 1 equal to? So it's basically stretching 0 and 1 out, and then we're stretching 0 to n to 1, and then we're stretching it to -1 to 1, right? And then here it's going to be the same. It's still going to be it's just going to be absolute value 2 times norm minus 1 minus 1. So what this basically is doing is that instead of being -1 1 -1 -1 -1, it goes to going it goes like this. It folds all of the negative integers up. It goes like boom, boom, boom. So there we get like these V-shaped. We get these V-shaped waves, which are basically our triangle waves, and then we're stretching them out. So the wave is just going to be equal to the amp times the triangle times the triangle. And basically that's our like normal waves. There are definitely more waves. There are like random waves, like Serum has that wave, and then like these waves, and then a lot of the other things. But these are the let's say the fundamental waves that we're going to talk about today, and I think we did kind of do that. I'm still going to add some of sounds in there, and then we're going to call that a video.